Okay, for number 3, you have to write the prime factorization of 36. So when I see the words prime factorization, I think factor tree. So what can I multiply together to get 36? Well, I can do 6 times 6. Somebody else may have said 2 times 18. Somebody else may have said 4 times 9. But I know 6 and 6 are not prime numbers, so I can break them down again. 6 is 2 times 3, and 6 is 2 times 3. So when I write the prime factorization, 36 is equal to 2 2's times 2 3's. Or if you wanted to shorthand it, you could say it's 2 squared times 3 squared. So I'd accept it either way. Okay, for 54, you can break 54 up into 6 times 9. And then 6 is 2 times 3. And 9 is 3 times 3. So then 54 is 1 2 times 3 3's. So I could rewrite it as 2 times 3 cubed. Okay, I can't break a 7 up because the only thing I can do is 7 times 1, and 1 is not prime, so you can't write 7 times 1, so you just say it's 7. And then for 75, 3 quarters make 75 cents, so I can do 3 times 25. 3 is prime, and then 25 is 5 times 5. You should get in the habit of like circling your prime numbers, that way you don't forget about them. So then 75 is equal to a 3 times 2 5s, so I could rewrite it as 3 times 5 squared. If I wanted to find the greatest common factor between 14 and 49, I prefer the factor tree method. So I would break 14 up into 2 times 7. 2 and 7 are both prime. And then I would break 49 up into 7 times 7. And then this is called greatest common factor. So what do they have in common? So the only thing that's in common is this pair of 7's. So the GCF is 7. Okay, for 6x squared, 6 can break up into 2 times 3. So 6x squared is equal to 2 times 3 times x times x. And then 5x squared is equal to 5 times x times x. And then what's in common? They have an x in common and they have an x in common. So my GCF is equal to x squared. Okay, for 13q to the 4th, 13 is a prime number because the only thing I can multiply together to get 13 is 13 and 1. So I can rewrite 13q to the 4th is a 13 times 4 q's. And then 2 is a prime number, so 2p squared can be written as 2 times p times p. So they have absolutely nothing in common. When you have nothing in common, your greatest common factor can only be a 1. Okay, for x plus 7 squared, I would write it out twice as x plus 7 times x plus 7. And then I would either do a box or double distributive. This time I'm going to choose to do double distributive. So I distribute the x over the second set of parentheses, and I distribute the 7 over the second set of parentheses. So x times x is x squared. X times 7 is 7x. 7 times x is 7x. And 7 times 7 is 49. So then I can add 7x and 7x together, get x squared plus 14x plus 49. You could have done the shortcut, which says just square the first term, which will give you x squared. Then multiply the two terms together. So x times 7 is 7x, double it, you get 14x. And then square the last term, you get 49. So if you recognize the shortcut, you could have done that too. Okay, this one I'm going to FOIL just to do something different. So I would do 2x times 2x, which is going to be 4x squared. Then my outsides are 2x and negative 1, which is negative 2x. My insides are negative 1 times 2x, which is negative 2x. And my last times my last, negative 1 times negative 1 is positive 1. So I can combine my negative 2x and negative 2x and get negative 4x plus 1. Okay, I recognize number 14 is a special case because they're conjugates. That means the exact same thing as in the parentheses except for the plus and the minus sign, which means I really don't have to FOIL. I could just do first times first and last times last. So I'd have x squared minus 25. The only reason that worked is if I had done a box, I'd have x plus 5, x minus 5. So I'd have x squared, I'd have a positive 5x, I'd have a negative 5x, and I'd have a negative 25. Well, the positive 5x and the negative 5x drop out. That's why you end up with x squared minus 25. So number 20, if I want to write a polynomial that represents the area of that figure, I would have to do length times width. So on the big square, it's x plus 3 times x plus 3. And then I'd have to add the little square, which would be x plus 1 times x plus 1. So that's a binomial times a binomial, so I can FOIL. So first times first is x squared. My outsides are 3x. My insides are 3x. And my last times my last, 3 times 3 is 9. Then FOIL again on the second part. X times x is x squared. My outsides are 1x. My insides are 1x. And last times last is 1. So then my like terms are a 1x squared plus a 1x squared, which is a 2x squared. Then I've got 3x and 3x, which is 6x. 1x and 1x, which is 2x. So 6x plus 2x is 8x. And then I've got a 9 plus a 1, which would be a 10.